Hello, and welcome to a look at Solid Edge 2023. I'm Rick Loring, a Regional Director of Sales with Maya HTT. I'm joined today by Jason Titcomb, a Pre-Sales Support Engineer. Before we get started, though, I wanted to introduce Maya. We're a full-featured engineering company providing services and software sales. We're a company currently of about 300 people, and 75% of these people on staff are scientists and engineers with hands-on experience in nearly every industry. We sell and support the technology for manufacturing, simulation, product lifecycle management, as well as AI and IoT. We help customers with automation, optimization, and customization of these tools, and we're constantly integrating them into Siemens software suite. We are actually an author of over 30 plus software modules for Siemens. And recently, we were named a #1 world partner for Siemens. But before we dig in, we want to spend a few minutes bringing you up to date on the Siemens strategy and the key role that Solid Edge plays. There's a lot of discussion out there these days about digital transformation, and you may wonder what digital transformation is. Car companies discuss becoming mobility companies, commercial aircraft companies becoming air transport companies. Some companies want us to help them build new business models. Others are asking us to help manage their software deployments. It's important for any company to consider digital transformation because actually those who don't risk being left behind. So what does digital transformation mean for small and mid-sized businesses? There's an industry analyst firm called IDC that recently did a survey where the focus was on SMB manufacturing and specifically on digital transformation. They surveyed hundreds of SMBs around the world, asking them about digital transformation, their strategies or plans, and recent progress. Important to note that 72% of the surveyed believe that digital transformation helps level the playing field for small businesses versus their larger competitors. So it's evident that digital transformation is a key part of the go-forward strategy for many SMBs. The survey also asked about technology priorities. Both cloud computing and software as a service really stood out. Nearly a third of SMB manufacturers surveyed said that they were prioritizing cloud computing, software as a service solutions, and nearly half of these categories would be a technology priority in the next 12 months. IDC notes that cloud is a great enabler for collaboration and analytics, and that's a good way to put it, because it's not about the cloud itself, but rather what you gain from it, and collaboration is the key. So let's take a look at a customer leveraging some cloud collaboration tools for meaningful impact. Harsh International manufactures farm machinery, industrial equipment, and hydraulic hoists. They're using new capabilities provided by Solid Edge SaaS to collaborate more effectively and reduce their design and development time by as much as 80%. 80% reduction in design and development time is substantial. A good example of what Solid Edge SaaS can enable.
Harsh International is a manufacturing company in northern Colorado. We manufacture everything from livestock equipment to hydraulic truck equipment.
Bob came to me with the idea to create a larger hoist, but one that doesn't have the cylinders swinging underneath the truck.
With Accelerator Share, we could click on it, send it to Bob. It didn't matter if it was over the weekend or he might have been in the office next door looking at it.
Those guys would be able to pull it up on their computer and just take a look at everything and say, this part could be a little bit different. And I was able to just bounce back those ideas really fast between all of us.
The need for people to be in the same room is not near as important as it was before. Now it's on a computer screen. Everybody knows exactly what needs to be done. As soon as they complete it, you see the result of that right there on the drawing, the 3D solid model I'm looking at. The time you spend addressing that issue is dramatically reduced. Being able to take that hoist from conception to fruition and then on to production in something in the range of 3 to 4 months was awesome. Hitting that market as fast as you can means taking advantage of that market as quickly as you can. That's what Share has done for us.
We love seeing companies like Harsh succeed with digital transformation. Siemens is committed to that mission. The investment Siemens made over the last several years has been phenomenal. Check out this slide and see a list of companies they brought into the digital industry software portfolio. Siemens has invested more than $10 billion over the last several years, and they've become one of the largest, most successful software companies in the world. In fact, Siemens is one of the top 10 software companies in the world. The result of that investment is Accelerator, a catalyst for the digital enterprise. Accelerator is our comprehensive integrated portfolio of software, services, and application development platform. The portfolio accelerates the transformation of business into digital enterprises and unlocks a powerful industry network effect. As a key part of the Siemens Accelerator portfolio, you can think of Solid Edge as your on-ramp to digital transformation. Focused on the requirements of small and mid-sized companies, Solid Edge enables manufacturers to create a comprehensive digital twin of their products that includes solutions for mechanical design, electrical design, simulation, manufacturing, and technical publications. It also includes solutions for data management and all the technical data that is created and consumed when creating and supporting the digital twin. It facilitates collaboration both within manufacturing companies and with external resources, including suppliers and customers. Solid Edge is your on-ramp to digital transformation. And Solid Edge assists in digital transformation for companies of all sizes, such as Chantiers de l'Antique, the communication and collaboration to help them turn complex concepts into comprehensive advantage for building the largest cruise ships in the world. So now it's time to share with you some of the really cool new functions that are in Solid Edge 2023. Create, connect, collaborate. Our featured customer this year is Yanu. Yanu is an Estonia-based company founded in 2019. And these images we're looking at is a fully autonomous bartending robots. They leverage AI technology. It serves drinks, handles payments, identifies, and communicates with clients in a contactless, hygienic, and highly efficient manner. This year's release of Solid Edge 2023, we continue to push the boundaries of product development, leveraging the comprehensive digital twin. With new capabilities such as simplified modeling workflows, value-based licensing, Solid Edge SaaS, improved interoperability with other CAD systems, Solid Edge Inspector, Kanban boards, and literally hundreds more. Solid Edge 2023 is the best release yet. Beta customers have already had the opportunity to experience Solid Edge 2023, and here's what a couple of them had to say. Francisco at Furioni was impressed with our focus on just daily workflows, and Zohar is excited about being able to work easier and faster. Solid Edge SaaS includes the next generation cloud-based technologies, specifically designed to help our customers collaborate with colleagues, partners, and customers in a secure environment. There are many other benefits that come with Solid Edge SaaS, so let's break this down. First of all, Solid Edge will always be the heart of your product development process with its powerful CAD and manufacturing preparation capabilities. But there's a new way to consume Solid Edge called SaaS. It includes things you love about Solid Edge, but quite a bit more. There's data management and security, the ability to have your data stored securely on the cloud and share with others. There's augmented reality, the ability to look at your product in the context of the real world. Collaboration, everybody working for a single source of truth, and they can share that data and can effectively communicate. There's mobility, anytime, anywhere, any device. And value-based licensing. Get the features that you need when you want them. Choose the add-on capabilities you want with instant access to tools like Generative Design Pro, Point Cloud Visualization, and Solid Edge Electrical Routing. We'll talk more about the broad range of capabilities as you get with Solid Edge SaaS here in a second, but right now let's focus on some of the great project management and search tools that are part of Solid Edge SaaS.
Let's take a look at Accelerator Share in action in this short demonstration. Collaborating with colleagues, partners, and customers has never been easier with new productivity and collaboration tools inside Accelerator Share for Solid Edge 2023. A new modern dashboard helps users understand the status of project deliverables at a glance via the Accelerator Share homepage. Collaboration and project management is simplified with the introduction of Kanban boards. This intuitive tracking process helps visualize work and maximize efficiency by displaying projects and tasks as easy-to-understand cards that are organized into user-defined columns. The boards, which can be used on any device, are a helpful tool during team meetings or to manage project progress. Adjustments can be made to a project by simply dragging and dropping. Also, the Share's search functionalities have been improved to help make sure you find the right file every time.
It's cool to see that modern dashboard that helps users understand the status of project deliverables at a glance. And I like the Kanban boards. It's really easy to keep track of things and just drag and drop to change project on a status. The new shopping style search lets you browse your data just like you do on shopping websites, but with common properties like name, file type, owner, date modified, and more. It's really a productive way to find and look at your data. Because Solid Edge SaaS leverages Accelerator Share technology, it offers integration with a wide range of Solid Edge and other Siemens products. So over 2,000 software subscriptions, including several in the Solid Edge portfolio, are now integrated with Accelerator Share. This enables increased cross-domain and cross-chain collaboration. The benefits of Accelerator Share grow with each additional subscription. The base plan includes 500 gigabytes of storage, and each additional subscription increases online storage by 5 gigabytes. So let's look at some mechanical design enhancements. Click less, do more. Right in the core of your daily work, you're going to find some great productivity enhancements. We've used some great lessons learned from synchronous technology and brought them into the ordered or history-based modeling workflows. We revamped the user experience and put tools right at your fingertips. Let's take a look.
Solid Edge 2023 continues to deliver enhanced workflows, promoting greater performance and increased productivity. Here we have the world's first contactless robot bar, designed and manufactured by one of our Solid Edge startup customers, Yanu, introducing a fresh and modern user interface which is consistent across all Siemens software products. All commands and environments have been refreshed and now provide an easier to use modern look and feel, but still at its core, Solid Edge you know and love. Following the introduction of the Context Toolbar in Solid Edge 2022, the capabilities are now expanded to part, sheet metal, and assembly environments. High-frequency object-specific commands are now at the tip of the user's cursor, improving productivity. Focusing now on the robot arm, we'll complete the design of a new glass holder. The material addition and removal workflows have now been combined into a single command. Also new is the introduction of automatic regions in ordered sketches. This speeds the process of sketching as it eliminates the need to trim sketch elements and project face edges. Closed areas are simply found automatically, as can be seen here as we add and remove material with a single extrude command. Notice the use of the Context Toolbar, meaning that all commands are at your fingertips. Changing an extrude feature to a cut couldn't be any simpler. Just edit the feature, change the option. When adding features, the spacebar can be used as a quick toggle between add and remove. Solid Edge 2023 also speeds up the process of direct editing in an ordered model by introducing synchronous capabilities in the move, rotate, and offset face commands. Here, the steering wheel is used to easily define the move and rotate directions, and design intent rules can be used to control the movement of other faces in the model. Here we can see this as we adjust two cylindrical faces and toggle the concentric option on and off. One final alteration on this part is to add an angle to the side face by using the rotate command. The enhanced workflow makes it a breeze. Since this is an ordered model, the move and rotate features are captured in the Pathfinder and can easily be edited later. The hole feature capabilities have also been extended and now have support for standard fit class tolerances for hole, countersink, and counterbore type holes. These conform to ANSI, ISO, and DIN standards. Support for unit tolerance has also been added. Solid Edge 2023 also introduces a new library of high-quality face styles. It consists of many common categories and thousands of different styles, ranging from additive manufacturing, coatings, fabrics, plastics, and many more. They can simply be dragged and dropped into the desired parts to add realism to any design. There have also been improvements to assembly features with the addition of new commands such as subtract, slot, union, and swept cutout. In this case, we'll add a swept cut to create a routed path through two components at the top of the design. The workflow is the same as it is in the part environment, but with the additional step of choosing the components to cut. Finally, there are new workflows to easily explore and visualize the internal components of any design with new Visual Explode command. Simply drag the slider bar to dynamically explode the parts on the screen, then drag it back to collapse the parts back into place. There's also a stepwise option, which intelligently explodes the parts and subassemblies in sequence and provides additional ways to visualize the design. Solid Edge 2023 continues to keep Solid Edge at the forefront of 3D CAD and stay ahead of the curve thanks to increased core CAD performance, new and improved workflows, promoting productivity gains, and the continuous implementation of user-requested features and functions.
It's really exciting to see how some of the great new technology from Synchronoss has been moved into the ordered or history-based environment, increasing productivity while speeding onboarding for first-time users. Regions are just a huge productivity saver alone, with the ability to just drag to define adding versus removing material. And finally, having true Synchronoss style edits in ordered modeling environment is just a game changer. Now, ordered direct modeling commands, such as move and rotate, make the use of the signature Synchronoss steering wheel to drastically improve the ability to edit ordered models. Here we have some positive feedback from a beta customer, Jan Boss at GIA. In addition to bringing some of the great technology of Synchronoss into order, we've also revamped the user interface to be a lot more fresh and productive. A clean, modern presentation of the command's options allows users to discover the capabilities of each command more intuitively and quickly. Similar to the presentation styles of many other computer-aided drafting solutions, the vertical command bars allow new users to adopt Solid Edge more quickly, leading to faster onboarding, increased satisfaction, and the lower cost of training. We've also brought the commands closer to the action. The content toolbar pops up to the highest frequency object-specific commands right at the user's cursor. With command options available right at the point of focus, mouse travel is minimized and improving productivity and streamlining the user experience. Here's a note from Mirko Markovic from Kaiser. He immediately saw the value of the new UI, noting that they can work more intuitively and more efficiently. And how about that visual explode? I think that's really cool. There's a stage mode that does the subassemblies first and then explodes down to the levels. Very cool stuff. We've also continued to build out our automated assembly tools by allowing users to capture common relationships and quickly replay them in new assemblies, as well as other daily productivity enhancements. Here's some another positive feedback from Jan. He's excited about the new Assign, Capture, Fit functionality. It's great to see all the new material and visual styles as well. This has been a collaboration across various parts of Siemens, not only to deliver very useful but consistent styles across all the products. It's as simple as drag and drop. Some interoperability enhancements. You can go further with your design data. The new interoperability enhancements unlock the power of your design for future-proofing your work. You can transfer Solid Edge data to and from the Accelerator portfolio of products, including NX and Process Simulate, and easily and accurately. Let's take a closer look.
Solid Edge is even more tightly integrated with other downstream processes and now has the ability to transfer assembly kinematic information to applications such as NX or Process Simulate in order to perform further dynamic studies or operations. In this example, we save time and minimize errors by transferring the motion kinematics of this robot arm from Solid Edge to Process Simulate. Starting in the Solid Edge motion environment, we'll make sure the kinematics are properly defined by selecting the parts, then choosing which ones are moving or fixed. This creates the 7 needed joints to replicate the 7-axis Panda robot. Once this is done, the motion of the robot can be verified by running the basic simulation. Now, the Solid Edge model can be exported complete with all the appropriate kinematic information and subsequently opened in Process Simulate. Once in Process Simulate, we can see that by using the Joint Jog option, all the relevant kinematics are present without having to do any additional manual setup work. The kinematic information of all the joints can be viewed by setting the modeling scope and using the kinematic editor. Here, kinematic relations are used to define the robot and simulate the reach movement. We can see that all the joints are correctly connected with each other in the sequence that was defined in Solid Edge. The movement can then be defined from the tool center point frame using inverse kinematic movements that are calculated automatically. Finally, we can simulate the action of the robot and see the exact movement needed to mix our drink of choice. Solid Edge increases productivity by providing even closer interoperability and integration with other solutions in the accelerator portfolio from Siemens, such as Process Simulate and NX Mechatronics Concept Designer.
So obviously we've done a lot of technical work here to enable exchanging important design information like joints, couplers, links, rigid bodies, and so on, but the real benefit to you is what it enables, and that is a broader access to the Siemens accelerator portfolio. For example, for process verification using Technomatics Process Simulate, or for true virtual commissioning with NX and Mechanical Concept Designer, the seamless integrations opens up a whole new world of possibilities via Accelerator. But we didn't stop with joints and kinematics. Material and physical properties assigned in Solid Edge are now seamlessly translated into NX. Again, it opens up a huge range of Accelerator options by providing consistent data for CAE or inspection application. Enhanced PMI transfer capabilities include section and model views and the ability to associate sketch and section view dimensions to a design body. This enhances interoperability with NX CAM and NX CMM and other validation tools. And we continue to build on our CAD Direct. In addition to NX parts, you can now insert SolidWorks, JT, STEP, Parasolid, either parts or assembly, into Solid Edge assembly directly without the need for translation. CAD Direct makes working and collaborating with partners, suppliers, and even different departments in your own company easier than before by supporting multiple file types without the need for everyone to be using the same modeling system. A great feature of this is that the solid bodies and surfaces can be inserted in the form of internal components. That means you don't have other files to keep track of because all of the parts are contained directly in the assembly, not individual part files. It's a great way to manage supplier data. So model-based definition, we're leveraging design and manufacturing intent seamlessly. The model-based definition enhancements give you the tools to capture design and manufacturing intent faster and easier than ever before. The Solid Edge Advanced PMI delivers high-quality, consistent dimensioning for downstream PMI, which is product manufacturing information, easily. So let's take a look at that.
Solid Edge provides new advanced PMI and model-based definition capabilities, allowing users to detail 3D models faster and easier than ever before, and to seamlessly share 3D model intelligence for downstream manufacturing processes and to other relevant stakeholders. New with Solid Edge Advanced PMI is the ability to automatically arrange dimensions on a 3D model with a couple of clicks. Simply select the needed dimensions and arrange them stacked or chained. If dimensions need to be arranged with respect to a smaller area of a model, there is an Arrange to Area option which makes this task easy too. This part lacks the necessary dimensions for the size and location of some of the holes. The new Auto Dimension capability takes care of this with ease. All we need to do is select the primary, secondary, and tertiary planes and select the features to be auto-dimensioned or even just auto-dimension the whole model. With support for planar faces, cylinders, and holes, it's never been easier to save time in dimensioning your model. We can even define tolerances to be automatically added to each dimension. The new Model View palette allows for fast interaction with model views and displays easy-to-understand thumbnail images which are directly derived from the model views themselves. Model views can be navigated by clicking on the images or using the arrow keys. It's also easy to create new views directly from the palette. Here we'll create a front view for our part to add some of the necessary dimensions to detail the overall height and thickness of the part, and also add a geometric tolerance for flatness. With new text box and notes library features, we can more easily add notes to the model views. These notes can include model properties, like the latest revision of the part in this example. There is also an option to keep the text parallel to the screen. The creation of drawings is a breeze through the new Model View palette. A right mouse click and selecting a template is all it takes to create a drawing. The same Model View palette can also be used in the draft environment. We will use it to bring in the front view and use the alignment function to ensure it's in the right place. The fit class and tolerance of holes can now be easily retrieved in callouts. Also, the ability to modify the color of cut faces on section views means it's even easier to differentiate internal details of a model and communicate necessary product manufacturing information. 3D Center Axis Annotation is now supported for appropriate geometry types, giving users a quicker way to add the desired product manufacturing information to their models. Section view dimensions in sketches are now associated to the design body, making it easier to use them in downstream processes. The copy to PMI workflow has also been improved. Now when copying selected 2D annotations and dimensions from a profile-based feature or sketch, once they become 3D dimensions, they are now automatically connected to the corresponding model faces. Selecting the PMI will highlight the associated faces. Solid Edge model-based definition allows designers to publish all this product information for use in downstream processes. This process is simple and easy, and the publish process creates a high-quality 3D PDF which contains all chosen model views and supports full view manipulation. Assembly documents can also contain a fully interactive bill of materials and much more. Solid Edge Advanced PMI and model-based definition capabilities provide new streamlined tools to detail 3D models faster and easier than ever before, and to seamlessly share 3D model intelligence for downstream manufacturing processes and to other relevant stakeholders.
I think it's truly important how we're moving the intelligence out of the drawing and directly into the model. Not only that, though, we're providing new levels of automation. The new Auto Dimension command increases productivity by automatically creating PMI dimensions for your part and sheet metal components. Plus, users can save custom schemes with tolerances and whole callout strings to standardize their dimensioning process. The Dimension Checker the Dimension Checker Assistant, that is, automatically check part models to determine if the part is over or under constraint. And Dimension Checker's color-coded results are displayed both in the graphical area and the interactive report and highlight constraint levels that identify missing tolerances. And I really love the Enhanced Mode View palette. It makes it so easy to manage which dimensions are in which views. So you can really visually see how things are going to be organized. Yet, if you still want to create drawings, they can be created directly from the Model View palette with a few clicks or by simply dragging and dropping. We've really built out the number of things that you can do in annotating with your 3D model as well. The text box annotation enables additional notes and other information into your 3D PMI. The notes and text boxes can be saved to a notes library on a server, saving significant time when applying frequently used notes to 3D PMI. The annotations can also set to always show as parallel to the screen as the model view is rotated. So here's the Solid Edge Inspector. You can automatically identify, label, and extract critical design characteristics. You can save time and money in manufacturing by eliminating errors in inspection. Solid Edge Inspector automatically generates quality inspection data and reports that users can trust while enabling seamless communication in the downstream manufacturing process. Let's check that out.
Quality inspection is an important competitive factor. Using Solid Edge Inspector makes inspection planning a quick and easy process. Taking a look at the side plate in the Yanu AI Bartender will open the drawing that already has all the manufacturing information defined. Launching Solid Edge Inspector, we can set the tolerance standards required. If needed, multiple tolerance tables can be configured, which later can be applied based on part type. Creating characteristic numbers with balloons is a quick and easy process. There is also the flexibility to create balloons manually or ignore some specific dimension types. Based on the standards and configurations which have been set here, the default tolerances get applied for the dimensions which don't have specific tolerances defined. These dimensions are highlighted in yellow in the characteristic table. At any time, the dimension class can be controlled to define how critical they are. The inspection balloons can also be shown or hidden when required. This inspection information can be exported into multiple file formats which later can be used in downstream applications. It's also possible to export this information as a separate project file which can be later re-imported into the drawing. This is very useful in situations where the quality team doesn't have write access to the CAD files. Inspection reports can be generated by choosing a template. These templates can be easily configured for any industry standard. The inspection data can also be easily updated to accommodate any design changes. Here, a change is made to the model and then the drawing subsequently is updated. At this time, we can also delete a dimension and add a new dimension. Then a click of a button updates the inspection data. This will add a balloon to the new dimension and updates the CN list with this and all other changes that were made. The changes like modified dimensions, new and deleted dimensions are captured as part of the CN list. Filters can be applied to these columns similar to Excel. As the design has been modified and the drawing updated, we'll generate the inspection report and see the updates. The list shows new, modified, and deleted dimensions. Filters can also be applied to the CN list in order to generate a compare report. This shows only the changes that were made when compared to previous revisions. The Solid Edge Inspector also fully supports a model-based inspection process. This means it can work seamlessly on the 3D model in the model-based definition workflow. Just like we saw with the 2D drawing, it's possible to create and edit balloons and generate a report on a 3D model using the PMI dimensions and annotations. Solid Edge Inspector providing a competitive edge by streamlining the quality and inspection planning process.
I think it's going to be a big time saver for a lot of Solid Edge customers. As you saw, Solid Edge Inspector automatically identifies, labels, and extracts critical dimension characteristics from 3D models and drawings. And unique identifiers are assigned that are linked to this design information over the entire life cycle of the part, through all changes, modifications, and iterations. Solid Edge Inspector saves users valuable time by automatically identifying and labeling the important information in up to 80% less time than manual entry methods. Plus, for increased downstream consumption and better communication with colleagues, the data can be extracted in different neutral formats, including Microsoft Excel. The first article inspection reports can be automatically generated and are essential to effective inspection planning. FIA reports can assist in locating errors that could later cause an issue in the product's life cycle, saving time and money by catching errors before the product proceeds downstream into the manufacturing process. On to simulation enhancements. Make the most of your mesh. Enhanced capabilities now allow simulation on convergent models. Those are faceted bodies. Expansion of the body mesh functionality to include assembly and sheet metal simulation reduces meshing errors and accelerates the speed of simulation studies. Let's check that out.
Solid Edge 2023 continues to accelerate the design process by providing powerful tools to help digitally validate designs and better build products in less time by front-loading the simulation process. We'll start with a generative design study which will help optimize the weight and material usage for the caster wheel component. After creating a new study and defining loads and constraints, new for Solid Edge 2023 is the ability to define the maximum displacement for a point on a given face. This helps guarantee the model has the appropriate amount of stiffness in a given direction. Also, planar symmetry is a new shape constraint that optimizes the model across 1, 2, or 3 orthogonal planes. This ensures the optimized model will result in the best possible symmetric design. Viewing the results, we can see that both sides of the model are identical due to the planar symmetry constraint. Selecting the Show Stress option gives immediate feedback on the areas of high stress concentration so we can adjust our model if necessary. The optimized generative design is a unique hybrid model that combines both BREP and mesh geometries, which can be sent directly for additive manufacturing. Moving to structural simulation, Solid Edge 2023 now supports the ability to analyze these hybrid mesh and BREP models. This allows us to easily validate the results of a generative study by applying the same loads and constraints to a new study. The body mesh option, which is now available in part assembly and sheet metal environments, has some new options which allow the resulting mesh to be simplified and improved by defining parameters. In addition to producing good quality mesh, it provides automatic geometry cleanup of small faces and edges. After solving, we can analyze the model and see that the areas of high stress match the results we saw during generative design study. A new check element quality command has been added, enabling us to view and report on any poor quality elements created when meshing. There are 14 Nastran quality checks available. Selecting Show Elements highlights and displays the warning and error elements in the model, as well as generating a report containing a summary of error elements. There are no errors in our mesh, but a few warning areas could be improved for future study if needed. A great usability enhancement in Solid Edge 2023 is the ability to reuse an existing mesh. Here we'll duplicate our study and bring the mesh with us. We want to test the model again, but with a higher load at this time. By reusing the mesh, we're able to save valuable time by not having to remesh the same geometry. This enables us to quickly run multiple iterations of our study, ensuring the design meets all of the necessary requirements. Solid Edge 2023 further enhances our robust simulation capabilities, saving valuable design time and reducing material and testing costs.
This is actually pretty remarkable. Although in theory, generative models are created based on the actual part stresses, we find some customers want an extra validation pass using proven SimCenter Nastran solvers. And with our unique Siemens technology, we can mesh a mesh. So you can perform simulation studies on a convergent model that were created using generative design or reverse engineering, enhancing Solid Edge capabilities to seamlessly incorporate mesh-based geometries into the design process. The functionality of body mesh, which frankly is truly amazing and unique Siemens, and this is unique to Siemens, has been extended. Originally introduced in Solid Edge 2022 for parts, it's been expanded to support assembly and sheet metal simulation. So we continue to build out the core of simulation, the stuff that you do every day. So support for duplicate meshes and extensive quality checking has been added. Generative design has received significant upgrade as well. New generative design commands, planar symmetry, and maximum displacement constraint give users the ability to do studies faster and more effectively than ever before. Let's look at some manufacturing enhancements. You build the impossible with new manufacturing capabilities. Solid Edge CAM Pro enhancements let you machine parts more effectively while giving you the ability to create more shapes, including those that would otherwise be too expensive or even impossible. Let's take a look at that.
Transform your manufacturing and maximize your design data with the powerful automated solutions of Solid Edge's integrated CAD/CAM solutions. Starting with some 5-axis machining, we'll focus on this part. Since it has features on all sides, a 5-axis approach will allow it to be machined in one single setup. The fixture has also been designed completely in Solid Edge. This is using a window frame technique where the stock body also serves as the holding device. A single button click sends the whole fixture and part to CAM Pro, while opening an existing setup that has some programming work already done. Solid Edge CAM Pro 2023 now supports adaptive roughing cut pattern for 5-axis roughing. This means very efficient machining and expert control of the stress on the cutting tool and extending tool life as a result. Here we'll also look at the machining simulation. This is another great innovation of Solid Edge CAM Pro, the ability to perform G-code based simulation. Here the machine motion on the virtual machine is being driven by the actual G-code file. We can visualize all the motion while the G-code file is being run, a true example of the digital twin. Another great enhancement in CAM Pro is the addition of Smart Machine Kit Simulation, or SMKS, with the PostHub portal. There are packages covering 3, 4, and 5-axis G-code simulation. Each package provides access to all the machines in that group. Also, PostHub can now be used as a repository for other things other than post-processors, for example, best practice documents, technical libraries, and more. Another new capability is the ability to perform rotary roughing on 4-axis machines. Not only is this operation easy to use, but as the machining simulation shows, it does a great job with the spiral groove or any other 4-axis feature. Solid Edge Cam Pro 2023 also introduces a brand new wire EDM capability. This makes programming these operations a breeze. Transform your manufacturing and maximize your design data with powerful automated tools of Solid Edge's fully integrated CAD/CAM solutions.
It is so satisfying to see the CAM capabilities continue to grow and grow, built on the best CAM code in the business. The new 5-axis roughing enables customers to spend less time creating CNC programs while ensuring better tool paths and faster machining throughout. With the new rotary machining for 4-axis, improves users' ability to create shapes and even previously impossible ones. Plus, the new wire EDM functionality rounds out the offering to include an extensive database of wire EDM machines. Standardized, professionally built machine simulation kits are available in the easy-to-access library through the Siemens PostHub. The Smart Machine Kits library eliminates the need for time-consuming, expensive, custom-built post-processors and machine simulation kits. So technical publications. Create technical publications even faster. There's a new modern user interface for Solid Edge technical publications, and enhancements to the usability, the workflows, and the animations will let you do even more with your illustrations and technical docs. Let's take a look at that.
Solid Edge 3D Publishing speeds the process of creating compelling and engaging technical documentation such as installation, maintenance, and instruction manuals, which are essential to business success and product performance. Let's dive into the creation of this document for our Yanu AI Bartender. With a fresh and updated user interface and improved performance, creating documents with Solid Edge technical publications is a breeze. A new Pages tab allows for easier navigation of documents. With a thumbnail image available for each page, users can now navigate to documents simply by clicking a thumbnail image to go directly to that page. Also new is the ability to assign rich text to metadata and illustrations. Here, text styles can be fully customized to fit your needs. Animations play an important part in conveying different messages and features in documents, whether marketing or instructional. Here, a new transition editor makes it easier to create custom transitions with user-defined timing and camera movement, part reveal, and other animation features. There are also 2 new animation types, flash and fade. Here, flash animation is being used to highlight the LCD screen, and then a fade animation slowly hides the screen in order to focus on the robot arm and its animation. Also new is the ability to use simplified parts and assemblies, family of parts, and family of assemblies. For the Yanu instruction manual, we'd like to hide some key details on some of the parts in order to protect our intellectual property. To do this, we can easily replace the detailed parts with their simplified representations. This is achieved with the update command. Solid Edge 3D Publishing then takes care of replacing them in our model, all achieved quickly and easily without having to recreate the document from scratch. With this year's release, users can also define multiple master pages to help with document creation. This provides more versatility for larger documents. Shapes can act as fully actionable items in Solid Edge technical publications, so users can customize them for various purposes such as switching illustrations, customizing views, or even directing to web pages. In this page, we can use the buttons to switch to a different color of the Yanu AI Bartender. Documents can be published to all the latest industry standard file types, including 3D PDF, HTML5, raster, and vector images. Here, the completed instruction manual is in HTML format, and users can access this information without any additional software and open it in any modern web browser. With Solid Edge Technical Publications 2023, creating technical documents and interactive manuals has never been easy.
It's clear that the new modern user interface makes Solid Edge technical publications faster and more responsive than ever before. There's just so many enhancements, but a few favorites are the ability to flash and fade parts during storyboard animations. The leader line outlines provide better contrast and visibility when highlighting content and illustrations. And a new support for Solid Edge simplified parts and assemblies can significantly reduce the file size of illustrations and/or your technical docs without sacrificing the intended message or instruction. So on to value-based licensing. You get the features that you need when you want them. So value-based licensing is part of the SaaS subscription, gives you access to a wide variety of Solid Edge portfolio products without having to buy each individual product. Use what you want when you want it. Here, let's look at that.
New for Solid Edge, value-based licensing, a flexible licensing option to help you with the challenges of a rapidly changing development environment. This approach allows you to discover new Solid Edge add-on products while increasing flexibility for you and your team. Let's have a look at how value-based licensing works. Starting with the base application, Solid Edge Classic or Premium, value-based licenses offer a fully flexible environment in which users can explore different functionalities. Companies acquire a set of tokens which allow the running of a wide array of applications. Tokens are available in yearly subscription packs that make the add-on products available as a single shareable bundle. Tokens can be checked in and out to allow for maximum flexibility. Each add-on product consumes a defined number of tokens when in use. The total number of applications and which specific applications that can be checked out is limited by the number of tokens users have available. Value-based licensing is even more flexible when combining multiple users, each with their own desktop and set of tokens. Just imagine a worker is confronted with the maximum token limit. By having a joint token pool, the limitation is automatically lifted as he or she is able to claim unused tokens from a colleague. In this context, it's also perfectly possible for users to use the same application simultaneously, as long as the token maximum isn't reached. Value-based licensing gives you the ability to manage cost, discover new applications, and easily scale your business. In many cases, the total investment is less than individual licenses, yet the flexibility dramatically increases, regardless of whether the modules are used daily or occasionally. Value-based licensing, new for Solid Edge, offers a truly flexible, cost-effective, simple-to-scale approach that reduces risk over time and encourages users to maximally explore new possibilities.
I think you guys are really going to like value-based licensing. I mean, check out the list of products here. These are all valuable products, but are you going to use each one every day? What if you could just mix and match and decide what you want to use at any time without having to buy the individual products? Well, here you can. Generative Design Pro, Point Cloud Visualization, Solid Edge Simulation Advanced, and all the others you see here are available on value-based licensing. It's only available as part of the SaaS subscription. Value-based licensing provides flexible, cost-effective method for users to run all those Solid Edge add-on products that you just saw. It grants access to multiple products through a system of tokens. Tokens are available on a yearly subscription in packs of 25 and 50 and make the add-on products available as a single shareable bundle. Tokens can be checked in and out to allow for maximum flexibility. Users can mix and match the add-on products as needed within their permitted token allowance. It's really the ultimate flexibility to give you access to technology you never thought possible. The Solid Edge portfolio of products supports digital transformation through a powerful, comprehensive, and accessible set of tools. You can, of course, continue to buy Solid Edge in its traditional perpetual form, but Solid Edge SaaS is available as well with its expanding cloud-based collaborative set of tools and value-based licensing. To learn more about Solid Edge SaaS and the benefits it can provide you and your company, please reach out to Maya for additional details.
Hello, this is Jason with Maya, and today I'll be guiding you through what's new in Solid Edge 2023. We're going to do a mechanical design enhancements deep dive. First, we'll look at user interface. Really nice refresh of the user interface and color scheme for 2023. You'll see a restructuring of the left navigation and also the start and the learn pages. You'll see some nice improvements in the Discover tab for new users as well as experienced users. Modernized look and feel for the command ribbons, and also context toolbars are a new capability or expanded capability. You'll see your Pathfinder has a nice new look and feel. We'll cover all of that in a quick demonstration. Let's take a look at what's new in Solid Edge 2023 in the way of user interface updates. So here you can see we're on the File tab. I'm in the Discovery area, and I'm on the Start tab. There's some great content here, videos for creating, for learning, and a quick UI tour. Maybe you want to create new documents and you could have this start. So I would encourage you to just explore a little bit any changes that you might notice here. Of course, on the Learn tab, there's even more, some advanced tutorials. I like to point out the About Solid Edge is sometimes useful down here. You can check for updates. You can see how many days are remaining if you happen to have a subscription type license, or what products may be consumed. So all very cool stuff. So let's take a look at the Yanu automated bartender. This is a pretty cool data set. I like it. So one of the first things you'll notice is a refresh of the icons. I actually really like them because they line up with our Solid Edge Cam Pro manufacturing solution. It's more consistent between the two applications, and for older users it just doesn't take that long to really get used to the new icons, I don't believe. I've actually come to really like them personally. There's something about the eye icon that I really like. It seems to make it easier just to poke that and hide and show components or maybe individual features in Pathfinder. The context toolbar is now been expanded into other areas in the software. We started to see it in sketching in the previous releases, but if you select some, you could see this toolbar is a little different. If I select something like a reference plane, I have reference plane specific things that I can do. Really reducing the mouse mileage. That's what I like about it. And of course, if you select a component in the graphic window, you'll get it as well. Now notice though that as you move your mouse further away from that, it diminishes it, and at some point it will just go away. So if you're flying around with your mouse, you may if you had too much coffee today, maybe you'll see that disappear, and that might explain why. But other than that, it's your very familiar commands: edit definition, edit in place, or open completely, or you can just hide. Again, really just cuts down on the mouse mileage, in my opinion. The Finder is something you shouldn't overlook. Let's say I want to search on 1494. So this is just a fragment of the file name, and it's showing me what subassembly that resides in. Now, I have a setting in my options so it does not automatically expand that out. That's just my preference, but there is an option in preferences so that will automatically expand upon selection. But you can very easily right click and now use scroll to, which I kind of like a little better personally, but you have the choice. And then of course you can also do a zoom to, which is kind of handy. So that's a graphic window based on, graphic window zoom based on what's selected. So kind of like that. In this case, we might just open right into that sub-assembly. And I think we have a little display configuration here. I'm just going to double click that and to turn on the component that we've started to work on here. And again, just touching the sketch in that subcomponent produces the context toolbar, and I can very quickly open that to begin work on my part as well. This is just an example of a workflow where I decided to open these documents in separate tabs. So that's just a little quick start overview of the user interface. We'll be talking more about that as we go. Next up is part modeling. Regions and ordered sketches. This is a great addition. This is something synchronous users have enjoyed for a while now. It's been integrated into the ordered modeling process as well. You have complete control over whether those are activated and whether they're created automatically when you create a new sketch. I'll be demonstrating that. Closed sketch indicator. This is something I've seen with new users when they create a sketch and they're unaware that it's not closed. They attempt to return to the 3D environment. This will streamline that whole workflow to show you these closed regions, and you can turn that off if you want. Great capabilities. I'm going to demonstrate where we have really nice control using the regions in ordered sketches. We'll talk about these internal loops. Again, something that we had in synchronous modeling, but now is in the ordered modeling as well. The unification of the buttons as far as extrude and revolve. So there's now just one button, and simply by using the automatic, which works great 99% of the time, or you can deliberately override, and I'll be demonstrating that. Let's take a look at the new region selection in Solid Edge 2023. We had this capability in the synchronous environment, but now it's been brought over into the ordered environment. It's a very welcome change in my opinion. You'll notice that we have one region here already showing on one of these sketches, and the reason is it's been activated, and to use it, it's simply a matter of selecting the region, using your context toolbar, and in this case it's a single closed boundary in a sketch, so it's very quick work to simply select the revolve axis and finish that and make an extrude. So to activate regions of existing sketches, it happens two ways. Upon sketch creation of a new sketch, the regions will automatically be activated. You can then right click here in Pathfinder and deactivate those if you like. But first let's take a look at the actual sketch. We'll jump into the Edit Profile with the Context Toolbar. You'll see these yellow shaded areas. These are closed areas that can then be utilized as regions later. But you'll notice there's much less trimming here than you would normally see. In the past, you would have to trim these boundaries to be one continuous set of elements for an open profile or a complete closed set. So the light yellow areas indicate areas that could potentially be used as region selection in the future. So we'll go ahead and close out of this sketch. So to activate the regions, as I said, you can just simply right click and activate the region. And now you see the shading of the regions, very much like you've seen in synchronous if you're familiar with the synchronous model. So now I can simply select a region. The context toolbar will give me the ability to extrude, or you can use the button on the main toolbar if you'd like. And I'm just going to give this a tab and click. Now don't overlook another capability here is the ability to include and exclude and use only external loops. So let's experiment with a couple of those, and we can just accept with the green check mark to see the immediate feedback. This is really nice that you can experiment with this to see the different results that are formed by those regions. So we'll just choose the top option that I originally started with, and I'll go ahead and hit finish. Now while still within the command, you can continue. You can pick sketch elements as usual, or you can go ahead and pick more regions, and I'm just going to right click as we normally would. I'm going to use my key point in this case just to pick up the midpoint to be a little fancy, and I'll just finish out of that and cancel. So at any point I can just hide that sketch and the regions will disappear. Let's go ahead and turn on another sketch here and activate the regions there as well. If you have more than one sketch active, and so there's more than one region, you can simply use your quick pick to grab those areas. So in this case, I'm going to tap my space bar to allow me to in a very relaxed manner just pick more regions, and then of course the context toolbar really cuts down on the mouse mileage, allowing me to just pick those other areas in a very relaxed manner. we'll talk more about the extrude and revolve in another demonstration here. Let's go ahead and just illustrate how easily we can edit the definition of these as well. One question that may come up is regions are typically closed profiles, so the behavior that we get with this outer area would be a little bit different. If this were done with an open profile, you would get this morphing to the outside taper. You can certainly still achieve that by using replace face. It's almost the exact same capability where you replace one face with another. So then when we go ahead and make a pattern out of this, again using the context toolbar, makes for very little mouse mileage. And I'll just probably make a simple circular pattern. Maybe 3. And I do want this to be a smart pattern. And go ahead and finish. So you see that we can certainly go back and make changes to this. These regions are actually history based. So if I go back to that step, you can do all the familiar actions like using the shift key to remove regions and finish. So you can see very nice capability in Solid Edge 2023. Expose local profiles as sketches. This is also a really nice enhancement. Sometimes you create a feature with the profile internal to the feature and then later wish you could easily reuse that 2D geometry in another feature, and this is a great way to move it out into a sketch. This is a great enhancement where internal profiles that are created when you initially create a feature, in this case a lofted protrusion, which is probably a little unusual that you would create all of these within the feature. In the past you'd typically create them as sketches first, but maybe a standard protrusion, it's very common to create the profile within the command rather than creating a sketch first. So you have the ability now to pull those out into independent sketches and also have control over the display in Pathfinder. If you right click in Pathfinder, we've had a lot of these options already in the past, but you now have the ability to hide and show profiles, so that will clean up your Pathfinder if you want to turn that on. And it's to pull these out and make them independent sketches. It's a simple matter of right clicking and choose move to sketch, and you can see that this now is completely, it's still associative, but it's moved it out as if it was done as a separate sketch. Sometimes you do a feature and you think, oh boy, I wish I had done that as a sketch because I can use that information elsewhere, and it makes it easy to do that. You can also do it with multiple profiles. In this case, we can do multiple select and choose move to sketch and essentially pull those out, but they all remain fully associative. So pretty cool little improvement. Also, object action is now more supported, more commands introduced where you can first select the object, and very often the context toolbar will appear offering you the action that you can perform. Traditionally, Solid Edge has been more of a action object where you select the command being the action and then you pick the geometry being the object. So this is much streamlined in many cases. Just maybe take a little time and notice it and maybe try to take advantage of it, and you'll see that it may be an improved workflow for you. Fit and class, continuing to improve the information captured inside a whole feature, things like class and more control over tolerancing for things like counterbore depth. All this information then can be saved in your favorite settings, and it can also be then presented in the way of a PMI dimension or annotation, and of course into drafting as well. And I have a demonstration on that. Left-handed physical threads. Physical threads were introduced previously in earlier versions. If you do any 3D printing, it's very nice to be able to have the 3D model represent the threads so you can print them. And this is a nice addition to be able to have left-handed threads, be it as rare. Next up is assembly modeling. Improvements to assembly features. They've added the swept cutout, union slot, and subtract, which is really nice actually. We have a demonstration for that. Very much like what we talked about, object action. There's also some of that capability within the assembly environment. After selecting the object, they can be executed either from the context toolbar or from the ribbon. Essentially, the context toolbar is going to pop up when you select things, and that will give you an idea what kind of actions you can just go ahead and perform using the object action, or of course you can use the main toolbar. Assign capture fit. This is not completely new, but it's been improved, and if you're not using it, I'd encourage you to take some time and learn a little bit about it. You essentially can better teach components how they go together, how they're going to be placed in new designs. Big productivity gains can be had there, and we have a demonstration of that. So if you haven't used it, you'll see how easy it is to configure and take advantage of that as well. And we have a demonstration. Let's look at the improvements with Assign Capture Fit in Solid Edge 2023, now supporting sub-assemblies. So our goal is to automate the process of installing the small sub-assembly shock mounts that go in these 3 locations. And we may have many engines of different models, and we'd like to always be able to place these shock mounts in a very rapid way, consistent way. So here is our little sub-assembly that we would like to mount our shock absorber. So we're going to go to the Tools tab and use Assign Capture Fit. Maybe you've used this, maybe you're new to it. It's a really cool capability. We're going to name this group Shock Absorber, and if you click Manage Relations, that will produce this dialog, but you can just simply apply this is like 1/2 of the relationship that you'll need to place this. So there's the mate, and now we want to do a axial. So you can see in the list we have a mate and an axial. 1/2 of the relationships required to place this sub-assembly. So the group name is important, and the sequence of the relationships is important. And we're just going to go ahead and now save the sub-assembly, and that information is stored inside the file. So then it's a simple matter of using your insert component, or just simply drag and drop. And when you do so, it will see that the relationships have been captured, and it's going to walk you through. So this option, also the assembly mode, is going to be automatically set to auto assemble because it sees that it's been taught. And now if you move around with your mouse, the only areas that will highlight are the ones that have the same group name as what I'm trying to place. So it's a simple matter of just clicking, and clicking. It's super fast, but it can be even faster if you can believe it. So we're going to go ahead and remove these and do it again. I'll like the insert component button, and I'm going to drag that in again. Same option with the auto assemble, except this time we're going to have it go find the destinations, and it finds that there are actually 3 appropriate locations for those shock mounts, and you can remove one if you wanted to. You have the control to do that. And then I'm just going to right click to accept. And then of course, if we want to insert component again, and if we did not have the appropriate receiving group name for some reason, or if you just wanted to go back to the older method, you can always use the capture fit, which is going to still walk you through the relationships that you need. We need a mate and an axial, so that's kind of the older style, which is still available and still very useful. So there you have it, assign capture fit. All right, assembly features, new edition, swept cutout within an assembly file, allows you to create a swept cut. You may remember we had cut and hole, but new is swept cut. We also have union and slot. I'm going to show you all of these. So for swept cut, we need some sketches, and we happen to have 1, 2, 3 sketches all ready to go. And we're just going to do a swept cut. And we're going to do a multiple paths and cross section. You may be familiar with this command from part modeling. And we'll go ahead and pick this as the path, accept, and because we're doing multiples, and you can pick up to 3 paths, we click next, and now we're on to cross sections. So we're going to do cross section, and it's just a square, so any corner will work, and then we can just accept, and the last thing that it wants in this case is it wants to pick the body or bodies that we want it to cut through. And so there's our cut done at the assembly level. Super easy. And then let's go ahead and do one that cuts through multiple bodies. That's we have a 3D sketch here. So we'll do swept cut. In this case, we'll do a simpler single cross section. Actually, we have another little sketch, little circle right there. And you can actually use the edge of the model if you want, or if you want to use the 3D sketch, you can do that as well. So we'll do it with the 3D sketch. And then we're going to pick the cross section. There's only 2 inputs required. And again, the last thing it's asking for, it says at the bottom of the screen, select the bodies to be cut. And now it's going to cut through both. Very cool. And we don't need to see those sketches anymore. And slot is just as easy. We have a little slot sketch here. We'll grab that. We'll choose the chain. And I've run this before. You're probably familiar with the slot command. I'm going to just do it through all, and I only need to cut through this one body, and we can just right click and finish. Just really cool, super easy. And let's take a look at this union. This is a way that you could possibly hide some proprietary information or reduce some complexity. So we want to kind of fuse these together as a single body. So you could do a union, and you select the target, and now it wants the tool, so I could pick more components and then just accept and finish. And so we have now an assembly feature. We have this union feature here, and if we actually turn off all the other components, you see that we have this one monolithic body that lives in the assembly. And same with assembly cut. We have assembly features now. We have cut, and slot. So great new capability in Solid Edge 2023. If you are in the habit of using sections, then you'll like this ability to color the section faces based on settings that you've set down inside the part. Get some really nice visual effects, and we have a couple of examples, and I'll show you this in a demonstration. Visual Explode, very dynamic I put this in the category of other view manipulation commands. Sometimes we get asked if we can use this in drafting or if it's part of the Explode, Render, Animate, and not currently. Who knows what the future will bring, but this is a view manipulation command. It's actually really cool. I have a demonstration. We'll talk more about it. And also visual styles, 1,000+ high quality styles that they've developed. Simple drag and drop operation, and they can map right over to KeyShot. Real easy to use. We have a short demonstration for that as well. So this is a nice improvement for face colors when doing sections. We already have a couple of section views created here. I'm going to maybe turn this one on. This is a straight section by plane. You can see that our lower component is not showing the color of the section, and how you do that is you select the component, you either edit or you open to get into the part file, and then when you go to your color manager, you will have an option for sectioned faces. And I'll come down here and grab green, maybe. Hit OK. And we close and return. And it's just that easy. So as long as that's set in the part file, you'll get your colored section faces, and that would work with any type of section, even a contoured section, using the section or the section by plane. We're going to take a look at the new Visual Explode command inside Solid Edge 2023. If you go to your Tools tab while working on an assembly, you'll see the Visual Explode command here. I think the key is in the terminology. It is just a visual explode. It's a little different than what you find in Explode, Render, Animate. This is just a kind of a view explode for the user, the designer, maybe to help him explore the design and refamiliarize him or herself with the design. You could potentially grab a screenshot, but there isn't really a way to persist this as an exploded view. So do think about this command a little bit differently than what's inside Explode, Render, Animate. Now notice I am rotating my space navigator at the same time, and now that I've put the focus on the slider, I can even use my arrow keys, which is very cool. So this is a great way for me to kind of explore my design and look around at things without having to necessarily apply display configurations or hide and show components. It can be a really nice productivity enhancement. And then there's also what they call the stepwise explode. This is really cool. This kind of uses a different strategy. It explodes by sub-assembly, so it actually allows you to see very quickly in a visual way what your structure is like, in a sense, because it first explodes the sub-assemblies as a unit until it's reached its maximum value. That I guess we don't really know what that is, but it's a built-in value, and then you'll see once it's exceeded that reasonable distance, it then starts to explode those sub-assemblies. So it gives you a nice sense for the structure in a visual way. And when you click to change that, it will collapse it back. So that's also a quick way to get it to collapse back if you wanted to, or when you close the dialog, it will also collapse back. So Visual Explode, very welcome enhancement in Solid Edge 2023. All right, let's take a look at our styles palette. You can see it's located right here. We have a number of kind of categories. You have the ones that are stored in your material table, ones that I've recently been using, all the styles, the ones that are in use on the model, which is great, and then you have a whole list of high quality styles here by category, even 3D printed, which is pretty darn cool. Now some of these have a bump map or a texture on them. So keep that in mind. I think I'm going to go ahead and make sure I apply my high quality view style. It's going to do perspective, but more importantly, it's going to make sure I have high quality rendering with textures. So we want to make sure that that's turned on. Really nice little search bar up here. You can just start typing maybe the color you're looking for. This is kind of based on the category, so if you select this, it should search within that category as well. And it's a simple matter of just dragging and dropping is one way. I actually really think this printed PLA is cool. It's kind of amazing. It looks exactly like a 3D printed version of this. And if you want to remove, you can just drag another one onto it, of course, but if you wanted to remove it, you can just simply select it and you can remove that last applied style. You also have a similar capability here in the, you can set this to none or to use the part style, which kind of strips all the paint off it and allows the part color to show through. Really pretty easy to use. You can see there's a number fabrics, glasses. So these over 1,000 high quality styles here. So if I look at my recently used, let's see, so soft touch black plastic I think would be good for the back of this. So let's go ahead and drag that onto the back, and you can see the texture showing through. And if I had more than one component, let's see, I can select this, tap my space bar, maybe pick this as well. I want those to be the same color. Let's go with a blue anodized. I'm going to just right click and apply that. So it's another way to apply instead of drag and drop. And maybe a red anodized. That looks pretty cool. Let's see, metals, aluminum buff. Let's drag onto one of the heads, and of course if there's multiple occurrences, it's going to ask me if I want to do them all, and I'll say yes. It's starting to look pretty cool, and these of course transfer over to your KeyShot very nicely. And where are these styles located? I'm going to show you where they are in case you are storing your materials on a central file server. You see where they are installed by default down in my preferences materials, where your material table is located. You have a folder here with the high quality styles. So there you go. Very fun. Encourage you to try it. Next up is product manufacturing information and model-based definition. Auto dimensioning for 3D PMI. This is not drafting. We had this in drafting already. This is for when you're working in the part or sheet metal environment and creating your PMI there. Not available in assembly yet. You can save your settings once you get it working the way you want it, and you can dimension the whole model or just a fragment. I'll show you that in a demonstration coming up. Lots of settings. We're not going to do a deep dive on all the settings, but what's great is you can experiment. It's well documented, and once you get it perfect, you can save your settings in that little field. And slots will be coming pretty soon, so you'll see everything that it can do in the demonstration. Range dimensions, if you manually create dimensions and you want to beautify them, this is very much like what we have in drafting. It will create alignment sets and just do a good job of arranging dimensions so they look really good. Doesn't work with auto dimensions, so keep that in mind. You'll notice they don't highlight. So if you ran auto dimensions and then you ran this tool, the auto dimensions don't highlight. Model View palette is a really cool navigation palette that gives you visual thumbnails that you can click on and some other really cool interaction to be more productive with your model views. It's an easier way to interact with the model views, and I'm going to show you that in a demonstration. Let's look at fit, class, and tolerance inside hole features and how to report that information on a drawing or inside a PMI. First, we'll click an existing hole. This is a synchronous part, but the same would apply to an ordered part. This is simply the parameters of the hole feature. So if we look at the dialog now, we have buttons that indicate that we have a class applied. You could see the green hue on the button. So for the through hole of this counterbore, we've set the class fit. We've chosen to apply tolerance using a standard fit as type, and then we choose the class, and then the tolerance is then in turn pulled from a text file. I'll show you where that lives at the end of the video. You can also apply a unit tolerance, kind of a non-standard based, and you can type whatever you want there as well in the case of maybe like a counterbore depth where a class isn't typically used. And if you give this a name and save this, all this information will be saved in the save settings. I'll show you where that file is at the end of the video as well. So then how do you utilize this either on a drawing? In this case, we'll use PMI. We'll use the callout inside PMI instead of the callout in drafting. And in case you don't use this, the %HC is created by clicking this button, or you could type it in. And that in turn tells the software to go get the information from the feature in the model. In the case of a simple hole, it would use this information, or a counterbore hole, it would use this information. So we'll do maybe these simple holes on the top, and if you click on a marker that supports formatting, the format button will become available. Here we can choose to retrieve the tolerance from the feature, which is very cool. And you can retrieve just the fit, like the H value, or just the tolerance, or the fit with the tolerance, and they provide the /F1, F2, F3. You can see after I select one, it types it in for me right here. So you could type that in yourself if you wanted to, so that's why they provide that information. So we'll go ahead and hit OK, and hit OK, and then I'm just going to place this. Place a couple of these. And you could maybe go and edit one of these after the fact and edit it, of course, just to illustrate how you might edit it. And we'll do fit with tolerance. And you can see now we get the fit and the tolerance. So we'll go ahead and do another call out. And in a simple through hole, I'm going to format this to pull tolerance information. We'll just get the unit tolerance information in this case. So there it's just retrieving the tolerance information that was put in, kind of not based on class standards. Very cool capabilities. Maybe one last example. We'll do a counterbore hole and choose a little different formatting. Fit hole over shaft. And if you're familiar with the class fit system, this would probably make more sense. We'll go ahead and hit OK. And you can see we get the H7 over H6. And I'll show you where those text files are. So in my case, they're down in the default location, which is in my preferences, but these can be stored on a central server location, and you can point to them through the options and file location. So the custom XML is where within the feature, if you type a name and click save, it's going to save it into the custom XML. And all the lookups for the tolerances related to the classes are stored in these text files, which also can be centrally located on a server. So that's it for ClassFit in Solid Edge 2023. Solid Edge 2023 continues to improve on simulation capabilities. Today we're going to look at analyzing an optimized model. Solid Edge can work with convergent mesh models or STL scans. The ability to combine boundary rep geometry or precise geometry with facet type geometry is a really great capability, and being able to analyze that for stress after you've worked with that type of information is very useful. We're going to have a demonstration for that. In this little example that I'll do, you'll see that we'll start with a generative design. Sometimes it's called light weighting. I'll explain that in the demonstration. It's a simple matter of turning on the design body so it acquires the material, and then you're free to work with your analysis. Mesh body was introduced in Solid Edge 2022. It's now been extended to assembly. So if you weren't aware of that, now is a great time to take a look at the mesh body. Really simplifies and streamlines the creation of bodies, of mesh bodies that are perfect for analysis. So better quality mesh with very few clicks is what that boils down to. Reusing an existing mesh. This is a time saver. You can now duplicate the entire study, and it will give you the option to copy the entire mesh, so you won't need to remesh. You may just want to experiment with different force vectors. So that's very easy to use, and very quickly you will see the benefits. And then check element quality. This is great when you have a very complex part and you really want a high quality mesh, so you get a good analysis. And this is a great way, before you spend time looking at your results, you can make sure that all your nodes are of high quality. So a great tool has been added here to allow you to experiment with different settings in your meshing settings to achieve just the optimal mesh and maintain high quality mesh. In this example, we're going to learn how to run a simulation study for stress on a convergent model. If you're not familiar with convergent modeling allows you to work with both mesh geometry, which could be the result of a scan, sometimes referred to as a bag of triangles, and also boundary rep geometry, which is more precise geometry created by typically sketching and then forming faces that are cylinders and planes, and like what we see on the screen. Another way to create mesh geometry is to use a generative design. So in this part, we like the original design, but it's too heavy. So generative design was used to lighten the part, and this is the design that it came up with. So this is the first chance I get to talk about the show facet edges options on the view. This is a great way to view the two types of geometry. So convergent is the blending of these two. You can work with both. So here we have our generative study. This is the result that we came up with for light weighting. We like it. We want to use it, and as a requirement, we just simply need to detach that from the study so it's editable after the fact. And then over here, we're just going to turn this into our design body. And you can see it takes on the material color. So you may or may not be familiar with design construction bodies with the multi-body environment, but essentially this becomes the solid material. It's just that easy. So then we go to our simulation and we'll do a simple linear static, mostly with defaults. I'm going to pick our mesh body as the input, and nothing too complicated. We'll fix these locations and we'll apply a torque to this location and we'll mesh. We want to turn on body mesh. There's some great capabilities related to this we'll talk about later. We're just going to mesh and solve. And solving pretty quickly. We should see results, and there we have it. Very quickly got our results, and do a little animation, and you could see the benefits of being able to analyze your generative study. Because you've taken away a fair amount of material, you want to ensure that the design is still strong enough to meet your requirements. In this example, we're going to look at the new body mesh option for assemblies in Solid Edge 2023. You see we have a study already started for this small assembly, but there is no mesh. Actually, the indicator here at the top tells us it's not completely ready to go. If we go and right click on it and choose mesh, you'll see that body mesh is the default. I might point out that with this checkbox on, if you go to the options, you'll see just options for body mesh, and there are a few settings here that are well documented in the help. If you search on body mesh, and if I'm going to hit OK, but to start with, we'll turn off the body mesh. Tooltip gives you an idea the benefits of using this option, and if you go back to the options, you'll see that things are a little different now. Just a little FYI on how the options are impacted. And we're just going to mesh, because we're not going to solve yet, because we're interested in the meshing by itself. And that looks good. It completed. So let's go to simulation, and we're going to go to check element quality. I'm going to check it for warnings and errors and choose show elements, just using the defaults. Give that a moment to process. And we can see it finds 13 faults. And I'll just close this for now. And we'll just go back to our mesh. This time we're going to use the body mesh option, and we're going to mesh again. And we should have better results just using the default options. Give that just another second so it performs its magic. You can already see by looking at the mesh that things are a little bit different. And then we will go ahead and do the check element quality with the warning and error, and choose show elements. And we see, of course, that we have no warnings and no errors. We'll talk a little bit more about this in another session. We have a couple more enhancements for simulation in Solid Edge 2023. Here with this simple part, I've gone ahead and done a study already. We've completed the mesh and we've actually solved it, and we could probably go ahead and solve it again. I'll just look at the results. You could see we have a fixed constraint where it mounts, and we have applied a force similar to how someone might pull on that. And maybe we'd like to analyze it for someone accidentally pushing down on the handle. We'd like to keep this study though, so you can simply right click on the study and duplicate the study. And this new ability to be able to copy the mesh is great, so I don't have to go through the steps of reusing that mesh. So we'll choose yes, and in the loads you can see we have a force here, and we're just going to go ahead and change that. We'll click on the steering wheel, and maybe we'll make that a downward direction, and we'll go ahead and solve for that again. Real easy to duplicate that and experiment with different scenarios. So another great example here is the check element quality. We have another part that I've done some work on, and we're just going to go ahead and mesh. We can right click and mesh, or we can click the button here to mesh. Let's start with something around a 4. We're going to leave the body mesh option on. We'll just go ahead and mesh. And I can close this. And let's check out the element quality. So check element quality. And I've altered this taper. This is all documented very well, but I'm just going to choose show elements, and we should see some visual feedback as well as some text feedback with worst case values. Very quickly get an idea if your mesh is of high quality enough before you go and perform the actual simulation or the solve. So let's go and change the mesh. Maybe we can just get away with using a higher value for the subjective mesh size, and we can mesh that. You can see some really pretty bad areas. So this actually looks a little better. We could use individual element. You can see we have edge size, surface size, body size. We have a lot of control over the mesh. But just to give you an example of how you might use the check element quality here, with this small part, it's pretty easy to just move the subjective slider up. So you can see we only have one error, which I don't actually even see. So just a good little example of the check element quality in Solid Edge 2020. This session is kind of a mixed bag of productivity tips. We're going to talk a little bit about some settings that are commonly asked about, maybe some workflow suggestions, and some common questions that come up. So I wanted to throw in that we have a settings and preferences wizard, which is a great way to capture your favorite settings and possibly transfer them to another machine if you needed to. Let's start by looking at some options that I prefer as preferences, and it also might expose you to some areas that you haven't looked at in the software. So we're going to go ahead into the Solid Edge options. We have a button on the quick access toolbar. In an assembly file, you'll have some options that you may not have if you're in the drafting environment. So I'm going to switch to drafting and look at some other options. So under helpers, the radial menu, I like to set this as fast as possible. I've got mine set to 100 milliseconds, which is a really quick time for that to show up, and I'll show you what I'm talking about in a minute. I don't like my video clips. There's a millisecond. If you hover a tooltip, I don't like the video clips on. It's only a millisecond, but I'm experienced enough so I don't need it. On general, I don't like the units to show in my input fields. Normally it will show IN or MM or whatever. Anytime you're in there typing a value in a dimension, it's extra characters that you may need to clear if you're typing a formula. So it's usually I'm working either in inch or millimeters, and I know I don't need to be reminded. So that's an option that I kind of like. On the view, we might talk about this dynamic preview in a moment. For assemblies, there's a little my preference for auto scroll assembly in Pathfinder. You know, if this is turned on, maybe you're just used to it, but what that will do is if you click in the graphic window a component, it will automatically scroll to it in the assembly Pathfinder. And if you have a very large assembly, sometimes that's not what you want, and I'll show you the alternative to having that turned on. That's just my preference, and I'm just making you aware of it as well. That's pretty good. Let's switch to a drawing real quick and jump back in there. Another one that I kind of like regarding the drawing view wizard. When I place a view of a medium-sized assembly, my computer is strong enough so that it can preview that subassembly quite easily. So for a medium-sized assembly, dynamically showing it, instead of just having a simple box, it will actually show me the graphics. So it might save me a couple of clicks to make sure I get the orientation that I want. And so I do like to have that turned on. Display is printed. Again, been there forever. That will show you a more accurate depiction of how a drawing will look if it's printed. Mostly with things like a hatch or a fill, because when you zoom in, they'll scale. But if you turn that setting on, they won't. It'll show just like it would if it was printed. And the line weights look a little more like what you would see when you print. So now the radial menu, if I just right click and hold, you can see how quickly that pops up. But if I briskly, actually we don't get right click in drafting, but if I come over here to a model, if I right click and release very quickly, or kind of just normally actually, just right click, you'll get your context menu for either the graphic window or in the context of an object. But if you just right click and hold, you'll get your radial menu. And to me, 100 milliseconds is really the sweet spot, because this is a really productive tool actually. So for example, I come here to my carrier. Here's a little example of how little I can move my mouse. So let's first select a component. I'll use the new context toolbar. There's a very short movement to get to that. Left click. Not going to move my mouse. Just going to right click and hold. Go to extrude. Select my face. Right click and hold. Grab my drawing tool because I'm in sketch environment or profile environment. Draw my little rectangle. Right click and hold. Exit the environment. And I'm right into my extrude, and I've barely moved my mouse. So just a little bit on workflow there. Okay, let's, I'm going to go ahead and open. I like to remind people about the push pins. I find people maybe don't use them enough or take the time to get used to using them. They're very productive if you have certain jobs you're working on. Push the pin in. Here's a little pro tip. There is a registry hack that you can employ. It's been in the community a couple of times. I'll show you where that is, where you can add functionality here. So instead of having to right click on every little one to clear out, you can clear recent or clear just the pinned or clear both. So these three can be added to this menu, which is really cool. If you have 100 documents here, I use it for if I'm showing things to a customer, I want to clean up other files between customers. I might have 20, 30 files here in the recent list, and so that's a really great thing. We also have the recent folders, which is really handy. It's just don't overlook that and don't forget about it. It's a big productivity enhancement. And I'm going to go ahead and just open an assembly. Again, don't forget about this top level only. So this is going to find only top level assemblies within that folder. Instead of all, it won't show the sub-assemblies. Now the last saved I like to use, this will maintain the activation state of the components as they were saved last time you worked on the file. So if you're working on a job all week, you probably want to open it with the same components active, and all I do is set this to last saved and click save as default. So now until I change it, that's going to be my default. And what that does is it just activates the parts that I'm working on instead of using the rules for small, medium, large assemblies and things like that. And you know, for example, I just happen to know that this is the component that I activated. But notice in Pathfinder what goes on. Maybe you have noticed this, maybe you haven't. When you hover, it shows me the branch that is living in. And as you move around components, it will show you in that beige color. Now when you click a component, it shows it in a light, faint green. But then of course you can always right click and scroll to. And then it shows it in the more solid green once you get to the final destination, and you see that one component is active because that's the state that it was in yesterday when I worked on it. One more little setting about the active and inactive. This comes up a fair amount. Here we have locate inactive parts. Now this is on by default, and what that means is, you know, when you're assembling and doing some other work, it will locate parts that are not active. Somehow they've enabled this functionality where even though it hasn't fully loaded it into memory, you can still access some edges. Now you might want that off. So in this case, if I were assembling, it wouldn't pick up any of these other components except this one that's active, the ones that I'm working on. And sometimes you might like that. So that's in the options, but it's also here as a button. And if you're working in the context of an assembly, like we were just talking about, so I'm going to edit in place here. Probably should have done this earlier. I'll just do a sketch on this face. There's another little option related to kind of interpart. So if you go to tools and then peers, so whether peer parts are locatable as I'm drawing. So if you're only interested, so I'm seeing the other parts, but I really don't want to highlight the other parts. So you can turn off peers, and now it only picks up the part that I'm working on. Kind of like if I did the Control Q, hide previous level, I'm down inside this block, right? So that's all I wanted to highlight. But so that peers button is one that it's also right here in this select group, which is pretty handy also. So peers, that's one that I think I've come across quite a few times doing support over the years. And let's switch over to this part real quickly. I have a sketch that I've created here. This happens to be synchronous, but it actually doesn't really matter. Just some things I want to make sure people aren't overlooking. If I go ahead and do a line, if you're in ordered, it's the same thing, but don't forget about the MICE. And it's telling me down at the bottom of the screen the little tips. So there's a couple of things. If I click and start to draw a line and type S for symmetric, it draws a symmetric line. If you do a line and you just hover and you really want to get to the mid, we'll type M on the keyboard, and the keystroke replaces the clicking of the key point. So if I come near one end and type E, it finds the end point, and it really is handy with arcs and things like that, that the center point might be cluttered with other geometry. I can hover over my circle or arc and type C for center, and now I'm connected to that center point very specifically. So that's a great way to get to your key points without any extra work with the mouse. And sometimes people also forget, lock to my sketch, need to just unlock. That same capability exists in the 3D environment. For example, here when I just move a hole, and if you were in order, this would work as well. Anytime you're keying off, you're looking for a key point in the 3D space. So in this case, I'm moving this hole, and I'd like to pick up another hole. You can see my key point is actually set to none, which is fine. What I can do is just tap K on the keyboard, and then you can use the mice. So if I want center, I type C, or you could just go and get to the center point. But if I just tap C on the keyboard, after that edge is highlighted, it's now found that key point for me using the keyboard instead of my mouse, and this kind of proves that it actually has picked up that key point. So K-mice is another capability that, and it is telling me right here in the prompt bar. So that's really all you need to know, is just look at the prompt bar. But so just a few little tips and tricks. Now we'll take a look at some drafting specific tips, specifically taking a look at part list and maybe some other options you haven't considered. We're going to take a look at parts lists, but first we're going to start here in the assembly and apply some custom occurrence properties. You have a file in your preferences folder called custom occurrence property XML, and what I've done is gone in and added a group called threadlock type. I've made it global. The behavior is defined in some text at the top of this file. I just wanted a simple pick list with an empty value if it wasn't applicable, or a nylloc. So just as some examples, a couple different threadlock types. And I'd like to apply those to components so that as they're used in this particular assembly, it may require a certain thread locker type. So I'm going to select my fasteners, and I've got a display config that allows me to select a few. I'm going to tap spacebar. These happen to be sub-assemblies for some reason, which is fine. And we will set the occurrence properties. Now, to acquire what was in that text file, you simply click this button and it will happen instantly, but what you might notice is the columns were added at the end. And then you can simply remove the ones that you don't want. And that's all I did to get my thread locker type column to show here, and then I set it on some arbitrary fasteners as some examples. So now we're in good shape to go and create a drawing with a parts list using our custom occurrence properties. I'm going to use my little template that I created, and we'll just place a little shaded view of this assembly. And I think we'll place it full scale. You remember in the earlier session I showed you how you can turn on the immediate graphic display on medium-sized assemblies. It works quite well on my computer, and then we'll just drop that down. Before I go too far, I want to show you the changes I made to the style. You have table styles and text styles that are interesting for configuring a parts list the way you want. You go into your styles and you'll see there's a table style, and I've made one called MM Standard, and you can see there's a few attributes in there, and then you'll see the normal, which is delivered. So this was made using this as a base. So the MM kind of inherited whatever was in the normal, so I didn't have as many entries to change, and I would probably recommend that rather than modify the existing, maybe create a new one. Same with the text. You might want to modify and make a new text style that you'd use on your table. You may use this, if you modify the normal, it may impact more object types in drafting than you really wanted to. It's kind of a happy medium. And then you would just go ahead and change the font. I think I had a support call where someone wanted Verdana, so we'll choose that as our text style. And then in the table style, we'll modify that. And I think something that's common is just line widths. Maybe 0.75 for a line width. You can see we get a little preview right here. And the text you can see is pulling in my MM Standard instead of the normal. And that all looks very good. So now we're ready to create our parts list. I'm going to click parts list and click my view. Because I've been playing with this, the place parts list button is not pushed in. I'll explain why that is in a moment. I'm just going to drop this down in a random location. You can see the auto balloons obviously happen, and let's look at some of the settings that I've tweaked. So in general, I do have one saved. I have gone through this before, and I've saved one for SEU 2023, and that's something you definitely want to do after you tweak a parts list just the way you want. That'll be saved to a text file, of course. The location, in this case, I think I would like it bottom right, and if I hit apply, I should get immediate feedback on that. What this gives you the ability to do is now drag this down and dock it, and if you want to be able to pick up the key point, you go to sketching and you turn on locate background. So now I can hook right on exactly, no more nudging and zooming in. You get your key points of that background. So that in this case is really handy feature. Let's jump back into the properties. Title, pretty straightforward. We'll just call that something silly. A lot of these are self-explanatory. I'm just going to show you some tips that I think might be useful. Item number, we could probably truncate the column header text a little bit. File name could just be file. Author, I don't actually even want. Quantity could be to save a little space. What we don't want is the column header names to be any larger than the data, so it will make the parts list wider than it necessarily has to be. So we don't actually want that. And you can see I've got some wrapping here with the file name. So the way that I would probably control that display is either through the format cells or by using a fixed data row height. You can see the separators here. You see column data and you see column header. So think about what area you're working in. I'm going to choose format cells, and we're just going to adjust the text to the column width and hit apply. Now our custom that was called Thread Locker, and we see that right there. We can double click that to add that in, maybe move that above, and we'll just turn that on. So now we have our thread lock type. This all looks really good. Data column, you'll notice that capabilities become available upon selection, so keep that in mind. We can insert a column here, but I'll show you another way to do that in a moment. Sorting, right now is sorting by item number. Pretty easy to select a different thing to sort by. In this case, I'm going to do it a different way. I'm going to use groups. So I'm going to enable the groups, and I'll give it a name. Just some arbitrary value, and we're going to choose thread lock type. Really simple example, and just go ahead and group my list items by that. We have a little bit of redundancy you could see here. So if we come back to our columns, and we could merge vertical cells with the same value. So this is going to get rid of that redundancy, so we can have kind of a cleaner look. A little tip, you can also have this column here for sorting reasons, but notice there's a show column checkbox, so you could have it there as a reference to be used in the sorting, but not actually show it. That sometimes can be useful. Now let's talk about item numbers and the sorting a little bit. You can derive item numbers from your assembly, and you set that in your assembly. You define your item numbers in your assembly file, and they would be pulled through into the parts list. Another really cool way, if you want, is if you select a balloon, the alignment shape will appear, and then if you select that, you'll have control over the numbering that shows up in the balloon. So you can redefine the sequence of the item numbers in a visual manner. So in this case, I want it to be clockwise. I want the 0 balloon to be this one. Give that a second to process, and then I'm going to click away. So you can see the item numbers are now 1, 2, 3, 4, 5 going in a clockwise manner. And of course my parts list has to be rearranged. Not a big deal. It only takes a second. And that's a really cool way, I think. If I was on the floor trying to find an item number in this list, I'd be able to look visually on my blueprint and easily find that number. So I could see that item number 6, I could just start at the top and count around and find item number 6. We see one item that has a star next to it. That indicates there was no place to hang a balloon. So it's in our parts list, but we have no graphics visible. So what we can do, and this is a little bit of a trick, I'm going to go and delete the balloons. I'm just going to select everything, hit a delete, and say no, I don't want to delete the view. That's just kind of a little hack. And I'm going to right click properties on the view, and first thing I want to look at maybe is revealing the part that we can't see. And we can see that item number 16 is the 13302, and I can pretty easily find that. And what we're going to do is change the display as reference so that it's not derived from the assembly file but manually. So I'm going to manually display as reference, and then I'm going to go and change this to visible and visible for the edge style. So this works with a shaded view, and Then another little tip, if you want to find components in a very large list, is to build a query. And in this case, let's do project name, contains, happen to know spring is in some of the project names. I'm going to hit OK, and I'm going to go select everything in the list and then execute the query. Otherwise, the execute may not, you need to select the top level node, I believe, to get your results. And I'm going to do the same here. I'm going to turn these into display as reference just for the fun, to make them seem kind of transparent so they're not obscuring anything. And I'll just change these to a visible style. Hit OK, update my view, and I did that wrong. That's okay. What I actually wanted to do was set the property on the plate that obscures it, and we'll set this, we'll untick displays reference on that, and then I'm going to go turn on my highlight selection. And sometimes you can just scroll down through and you'll be able to pick up visually when that component highlights. So this is the one that I want to display as reference. Hit OK, update the view, and now we can actually see inside. So let's run our parts list again. This time we're actually going to, we're using our MM standard. We'll select the view, but this time we're not going to place another parts list. We're going to just use the auto balloon. And let's check out the balloon options. I'm going to make this clockwise like we saw before. This time I'm going to use a rectangular alignment shape and an oblong balloon shape, and we'll hit OK. And I'm just going to left click on the screen. And obviously our parts list has gone out of date, which is fine. And you can see now it's been able to hang a balloon off those graphical entities because it can see them, and we have our order all the way we want. Very nice. And one last little tip of the day, under the select command you have Smart Select. Select a balloon type, it then we'll pick all the other elements by type, which will mean all other balloons. So we've only selected balloons. You can easily change this into a different style or something like that. We have a couple of an extra alignment shape that I can just delete. So there you go, some tips and tricks for Solid Edge 2023 parts lists. And finally, a few more miscellaneous items. 3D printing of threads and holes, and some common questions regarding mold design. Not a deep dive of mold design process, but just some things that have come up over the years. This is a question that comes up from time to time where a user would like to create a specialty threaded hole and actually have the threads modeled optionally for 3D printing. Everyone seems to have a 3D printer now, and they notice that after they print a threaded hole, sometimes the fastener won't go in, and they need to run a tap through it to clean it out after, and it seems to defeat the purpose of the 3D printer. So we can compensate for that by adding a little bit of extra diameter to the threaded hole and making a specialty record in the hole database. And you can see I've got this 1" 8 UNC, and I just put the P on the end for unique designation. And this is a standard. So we've got the minor diameter and the thread size, and I've done something similar with the outside diameter. And this is a 1". I made it grossly larger so we can see it visually. I made it 1" 50, and this one is actually 1 inch. And if we do a section on that, I think you can actually see, you can probably see the difference in the two threaded holes, and one has a little bit different chamfer on the mouth of it that may be nice to have for your 3D printed threaded holes. And I've deliberately left one without the physical threads. Now, big warning that you'll see in the documentation is don't just go use physical threads all the time, because it really can burden the graphics card because it creates so much more geometry unnecessarily. So what am I talking about? When you create a hole, you have a physical thread option here upon creation, and I've done that. If I create a hole or if I create a thread for external, you have this physical thread option where it will, at the time you create the hole, it will model the helix for you. Now, if you examine the dialogues, they do a good job of explaining how they find the information for the thread. There's a standard. I'm using inch. So they explain for external threads that they're going to use the nominal diameter in the database. And for internal tapped holes, if we look at the options, you'll see here you have these 3 radio buttons, and they explain this, and the default is internal minor, and that's the one that you want to use to get an accurate lookup according to the documentation. So you can see in the drop list now I have a 1" 8 UNCP as well as a 1" 8 UNC. So to get to that standard, you can open it in Excel, or you can click this button and open it. I find that to get it to reread the data in the Excel, you want to complete the command and just start a fresh command. Now I've set the option to model the physical threads on 1 external and 2 internal, but I left one off just to point out that on the 3D print you have the physical thread capability here, and they give you a warning about performance. To kind of just don't go crazy with this because it creates so much more geometry. But you can see I've applied the attributes to this, that it's actually a left-handed thread and it's my custom UNCP. So when I select that and accept, you can check the log if something didn't work, but I can see that it worked, so I'm just going to go ahead and finish it. And you can see we even have our left-handed thread, which is very cool. New capability in 2023, as you know, as fringe as that might be. And notice the LH, if we edit this and look at what I've done, in the symbols and values you'll find %LH. And so only if it's a left-handed thread it will output LH. If it's a normal hand, it won't output anything, and it's documented that way. And we'll take a look at the database. So here's my ANSI inch database, and you can open this from the command like I showed. I just happen to keep it open here, and you can see I'm on my threaded tab, very thoroughly documented on the instructions tab. I've added a thread family here, but that is actually only required if you have major diameters that are the same. So the nominal diameter, they call it. If you have redundant values here, you'll get a message that will tell you that for any single thread family, the diameters need to be unique. So this isn't necessary in this case, but I did it just to demonstrate. And this column, you pretty much need to leave those the way they are, or at least in my experience, it will report that there is an issue if you try to change that. And if you scroll, you'll notice there's more information to the right, and I've also input for my custom 3D printed hole a special chamfer offset and a start chamfer angle. So most of them are left blank. And if you scroll down quite a bit, you'll see that there's some information for tapered threads. If you're kind of wondering what some of these other columns are used for that seem to be empty, it's because they only apply to certain thread types. Now, if you're going to be making modifications to these files, there's a great little utility down in the folder where the Solid Edge executable lives, and you'll find documentation on this, and it's a whole database verification tool. So you can simply select your XLS and choose debug, and then view the report. And if you've done any bad things in the Excel, it will tell you what cell, row, and column you've made the mistake in. So that's a great tool to use if you're going to make any changes to this file. So we've had some questions over the years regarding making a mold and working with files from other systems, and this is like a little button membrane possibly that is part of the Yanu automated bartender. I thought I'd try to build a little storyline from this. So the story may be that we have some data that came from another system in a couple of different forms. So we'll go ahead and open that. In this case, we have a Parasolid, which is X underbar T, and you always want to check your options when you're working with a foreign file. You may want to turn on the heal and stitch. This will attempt to sew up edges that have minute gaps. There is a .ini file that controls some other settings, and that is stored down in your Solid Edge program file folder. I'll just bring up File Explorer, and there's a translators folder. And for example, I believe this is the one for Parasolids. There'll be some settings in there. They'd be documented as well, but if it's not on the dialog, then there may be some extra settings in those INI files for various file types. Also, if you're having trouble getting any results on an import, you could try turning off almost all of these settings. You probably want the log file to stay on, but with every one of these things that the software tries to do, it could possibly be not succeeding because of the file, and sometimes turning these off can yield at least something on the screen when you open it. It may not be ideal, but something to consider, and the help button will take us to some documentation. So we'll just go ahead and open this. This is a Parasolid, so it's going to ask us for a file to use as a template, and we'll just go ahead and do that. So this came through pretty straightforward. It looks pretty good. I see some extra, I'm not sure what that thing is even in the middle, but we'll get to that. One of the first things you want to do when you import files from other systems is most likely go to your inspect, and there's an optimize command. This is nice. It will optimize geometry that may not be quite perfect. You can emphasize the interesting edges that it may have some work to do, and you can check out the options and experiment with this. And just mostly this is an FYI. This is probably one of the first things you'd want to do. Once you start creating features, it's going to disable that option. So if you start creating some direct edited features there. So that probably did some work for us. And then you might continue and maybe do a little defeature. I probably want to use delete faces. Let's go grab some geometry here that's pretty clearly not something I want to have. So that's a great capability. So you'll notice at some point that optimize is going to not be available. So I like to do it early on. So now I've got some what looks like pretty clean geometry. Another great command is to go to your surfacing and use show non-stitched edges. And you select the body, And each one of these little green highlights is an area where the faces don't connect to each other, and sometimes they're really small. In this case, you could see that's just a minute gap, and we want that to be kind of sewn together, but it's still a little too big for the tolerances of the Parasolid. So that's just another great tool. And there's also in Geometry Inspector, you can run that as well. So under Inspect, we have Geometry Inspector. I probably don't want, well, actually small entities may be useful, but you should be able to quickly just run this. Though there's no faults, we have some gaps, and that's not always optimal. But sometimes you'll get the faults and they'll highlight down here in the lower area. Now, different file types have different behaviors sometimes. So as an example, I saved this out, this geometry that you see here on the screen. I saved it out as a step, and then I read it back in, and you may actually get a little bit different results. And we also have model compare that you could use if you were concerned that the fidelity of the model might be significantly changed. But that's something to consider as well, that the step tools may yield a little bit different geometry, and I can give you an example of that. I'll just close this, and I'm going to go ahead and open a step that was simply just done by saving as step. And if you check out the options, you'll see a little bit different options here, and we'll just go ahead and hit OK. Now this time I'm going to pick a template that I made. I thought this might be interesting. I made a template that has geometry in it, and it's called Mold Base. I just did this after I made my stock Mold Base. I just saved it into my template folder that I named SEU 2023. So now it's going to use that as my template, and I get to have my Mold Base there as well. Now you could certainly use part copy, insert part copy, and after you've opened your Mold Base, and you could grab this geometry, but it is going to want you to select, you can see the file types. I don't actually have, I have a Parasolid, which is nice, but typically solid edge files. So it might save you a step. It's mostly just interesting, you know, the notion that you can have a template with some geometry all ready to go in it is really the point of that. So we'll go ahead and run our optimize. We'll pick the body and let that rip. Looks actually pretty good. And now if we go to our surfacing and show non-stitched edges, we actually have fewer than we had before. So this is pretty good, but let's just go and run the importer again. I'll choose my part and make sure that Simplify Geometry is on this time. And we'll go ahead and hit OK and open that. We'll use our template. We'll do our optimize. You'll see that you get a little indicator next to your geometry until you optimize, as a little reminder that it might be a good idea because this came from another system. And we can see it did a little work here. And now if we go to surfacing and show non-stitched edges, we only see the perimeter, which would make sense. Everything else looks really good. So now we have a pretty clean piece of geometry that we can use to go ahead and create our mold. So clearly this is out of position, so we'll use our measure, and we could see that actually it looks pretty good. So at least it looks like it needs to be rotated 90. So we'll go ahead and use our rotate faces. This got so much nicer. I'm going to pick the entire body, and I'm going to set my steering wheel at a location here, and we'll just hold the shift key down and click on the disc until I get the orientation that I want. And now I'm just going to, without the shift key, just click, and we actually probably don't need the design intent because we're moving the entire body, but we do want to do a 90 degree move on that, and just go ahead and hit finish. And then we want to move the entire part, and that would be a straight move. Again, we'll choose body because we want to move the entire body, and I'll put this, actually why don't we do a couple of moves just so I can illustrate. So imagine this came in out of place, and what you can do is simply select the body, click and release on the origin of your steering wheel. That will place it at that location, and then if you click the blue sphere at the end, we can now direct the movement to a very particular, what might be a compound move, and then we can come down here and drop this right at that location, and so that should be perfectly mounted on top of that face. So at this point we've got a couple of options. We could, if we wanted to just fuse it on, we would use a Boolean operation. Now when you do a union, it's going to want to extend the faces so that it can create a closed area and fill it full of material. So we click the target, and we click the tool, and we're getting an error. And this is actually simpler than you would think. The brim at the bottom, you can see, is kind of sitting coincident with that top face. If we just simply delete that, we may have better results. Now in this case, if you can imagine, that face that was there is trying to extend itself outward until it solves to a valid solution. We'll go ahead and do that again, and that's where it may be just extending to infinity. So now we get a nice valid solution. And another common workflow, let's just back this up to, we'll get the delete face back. We want our part copy to be visible, and let's do another move, and I'll pick the body. I'll turn my design intent off because I just happen to know, well, I've turned off coplanars. It's because it's sitting on this face, it would have normally wanted to pull that up. But in this case, we can just simply grab the steering wheel, or if you want, you can drop it onto this face to be really confident that it's moving in that vector. And we can just move this up, let's say 0.5 inches, just to get it up off the floor of that mold. And then we're going to create an extrude. So we're going to go ahead and do a simple extrude, and we'll grab the edge. Now, one little requirement is this has to be no bigger than the geometry in this particular application. So we're not going to use a a finite distance and then Boolean. We're going to use the from to. So the from surface is actually already set, but we could just click it or we can right click through it. And then this to surface will be this geometry. But again, the requirement is that we'll let that compute for a second, and we'll hit finish and cancel. So if it needed to be bigger, you might need to expand the floor of that little hat, like the rim of the hat. And sometimes the surface color may still be there. We want to make sure we turn off our surface geometry, and you can go ahead and use your part painter. And I would probably set this to body and replace styles, and that will give us our uniform color. So hopefully that was helpful. Just some ideas with working on a molded type part.